Okay, so for 4.2, it's patterns in linear functions. So the first thing I want to talk about is what exactly a function is. So there's two things. A function has to have an independent variable and a dependent variable. Now, what an independent variable is, that's basically your x. Think of it as your input, just like that machine, like a function machine, like an input. And the dependent variable would be your output or your y. So you talked a little bit about this before last semester, but just think of it as basically your x is your independent variable and your y is your dependent variable. If you're dealing with the table, if you're dealing with the table, usually the stuff on the left or on the top is your independent, and the stuff on the right or on the bottom is your dependent variable. Now, what a function is another way to look at a function. When we're looking at a table, is that for every input there is exactly one output, or what we say, it's kind of none of the x's repeat themselves. So using looking at your guide notes, it says cross out the relationship below that does not show a function. So if you look at the first one, look at the input. When I input 1, I get a 2. When I input a 3, I get a 4. When I input a -2, I get a 4. When I input a -5, I get a 4. Now, that's okay that the y's repeat themselves. That's totally fine, no big deal. Now, if we look at the next one, the second one, when I input 1, I can choose to either get an output value of 1 or -1. And when I hit 4, I can either choose to go with 2 or -2. That one is not a function because it can pick which way it wants to go. The second one, when I input -1, I get 1. When I input -2, I get 2. When I input 1, I get 1. And when I input 2, I get 2. It's okay that the y's repeat themselves. Totally fine. So really it's that middle one is the one that doesn't quite work here. Okay? So, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using table, words, an equation, and a graph. Those are the ways that you can actually represent a function. You can look at a graph, you can look at a table, you can look at an equation, and you can even use words. So a few things on here is the idea is perimeter. Perimeter is what, if I had to highlight something, that's the magic word right there, perimeter. What does that mean? Perimeter means you have to add up all the sides. So let's go ahead and first make a table of this. So if we're making a table of values, you would basically say, okay, if I have a 1 by 6, one rectangle, I'm going to go ahead and put a 1 right there, a 1 rectangle. 1, what's my perimeter? 6 plus 6, that's 12, plus 2 more, that's 14, so that's 1 and 14. Then I look and I say, what about two rectangles? Well, if I add another rectangle to it, I now have 6 by 2. So 6 times 2 is 12, and 2 plus 2. So this is with two rectangles, and I guess that would be what, 16 if I do the perimeter, right? And then if I look at three rectangles makes it a 6 by 3. So if I do 6 times 2 and 3 times 2, what do I get there? Well, if I do that, then I get a 3, and I think I get an 18. And if I do 4 rectangles, then I have to add 2 more, so that's a 4 by 20. So there's my table that shows that right there. I could probably, if I wanted to graph or if I wanted to graph it, before I graph it, I want to see if I can kind of do it in Word or in an equation. Now, if I look at this, I could say something like, oh, I don't know, it looks like to get y, that would be the y. How is that 1 becoming a 14? Well, if we look at the rule, we're taking we're taking 6 plus 6, that's always that works, and then here's 6 plus 6 more, and 6 plus 6 more, and 6 plus 6 more, so that's always 12. So whatever we're doing, we're getting something plus 12, right? So now if we think of that, what else is happening? Well, we're adding, what this one rectangle was a 1, and then we're adding another rectangle and another rectangle, so that's 2 times x. Okay, so if you had to say it in words, you could say that if I multiply the number of rectangles in each figure by 2 to get the total length of the top, and then I add 12, then I get the perimeter. All right, I'm not too worried about the words if you can get the equation. If you look at if you look at this though, if you look at the plotting the points, you could go ahead and plot 1 comma 14. So if we go ahead and go to 1 comma 14, 1 comma 14. So if I do this and I go to 1 comma 14, see there's 1 and then 14 is probably right there. And then if I went ahead and did 2 comma 16, I went right there. And then I did 3 comma 18, something like that. Oh, nope. That's not the right way I want to do that. So 2 comma, was it 16? 16 is probably just past that. So 2 comma 16. I'm going to go right here. And then 3 comma 18. That's not working right. Let me delete those. And if we just do it by hand here, if we just go ahead and you just plot them. Let's just plot them. So we do 1 and 14. If you just do 1 and 14 there. You can do 1 and 14, so 1 and 14 is probably like right there. 1 and 14. Okay, so what I went ahead is I went ahead and plotted the points, and you want to connect. You could connect them with the line, but you can see that it does in fact make a line. Let's see if you got it. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, equation, and graph. So I want you to try to do this one in your guide notes. Just kind of use what we did in here. What I would do is I would look and make. First thing I would do is I try to make a table of values like an x and a y. So if you do like this, you have one triangle. It looks like 3 plus 3 is 6 plus 4 more is 10, right? So there's your 10. And then two triangles. On the second triangle, you have 3 plus 3 plus 4 plus 4. So the 6 plus 8, and you label that. And then you have 6 plus 12, and then 6 plus, looks like 4, 4, 4, and 4. So 6 plus 16. And think about all the constant things that happen there. Here's another example talking about photography. It says the table shows the relationship between the number of photos X you take and the amount of memory in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the function using words, an equation, and a graph. So what you could do what you need to do is you need to first take a look and see if it is in fact a linear function. Well, look here. What's the difference between these guys? If I jump up from here, that's a 1. If I jump up from 1 to 2, that's the difference of that is a 1. If I go here from here to here, that's a 1. But what I need to do is I need to see the difference between here. 512 to 509, what's that? That's a negative 3. And then this difference is a negative 3. And then this difference is also a negative 3. This is also a negative 3 difference. So yes, it is in fact a linear relationship. Now, the amount of memory left on the chip is 512 minus 3 times the number of photos taken. How did I get that? I don't know. I just kind of looked at it and seen if I could figure it out. So y equals, I know it's always going to start with 512, right? The maximum chip is 512 minus. And then how do I go from here to here? I can see I jump up from here I'd lose 3. From here I would lose 6. And from here I'd lose 9. So that's where it's minus 3 x. Okay? And if you look at the graph, you could just plot the graph. You could do something like this, and you could just go 0, 5, 12. You can put a dot there, and then here's 1. You can see that it just makes, and then here's 2. It's going to make a constant, here's 3. It's going to make a constant decrease um, situation. Go ahead and try to do this. Got it? A little hint is the relationship in the table at the right a linear function? Describe the relationship using words and equations and graph. Just use what we did um, just a second ago. Please go ahead and finish the lesson check and do you understand? And I'll see you in class. May the force be with you. Oh, I don't like that.